A parallel circuit is a closed circuit in which the current divides into two or more paths before recombining to complete the circuit. In this diagram, charges can travel from the source to bulb A and back to the source without passing through bulb B. The same applies to bulb B as well.
And then through here. We know that because these two are in series, we know that the current here is
The
equal
path
to the current
correspond to different complete
And they're
loops in the
identical
circuit,
light bulbs,
and each
which
charge
means
can only travel through one loop.
resistance.
In this case, if we add an open switch, charges can travel to bulb A, but not to bulb B. We can know that if one of the loads in the parallel circuit isn't connected or is broken, then no charges will be moving through that path, but other paths will continue to have charges flowing through them.
So what gives us the resistance?
Since bulb A and bulb B are in different loops inside the circuit, the same amount of charges will travel through each bulb. Therefore, both bulbs will have the same brightness.
Through the cells. But
These are the following rules that apply to a parallel circuit. The total current is equal to the sum of the currents of the paths. The addition of more bulbs in a parallel decreases the total resistance. That is because there will be more paths for the charge to flow through. This decrease of resistance causes the current to increase and ultimately give the battery a shorter life, as more current must flow out of it. Note that the total resistance of the circuit depends on the arrangement of the light bulbs. And lastly, the amount of voltage always stays the same in a circuit. In diagram 1, the potential energy of the source is 9 volts, and the current given out is 0.9 amps to each of the identical loads. We can know that the total current is 1.8 amps, and the potential energy remains the same. In diagram 2, the total energy is 2.7 amps. We can notice that the current increases by 0.9 amps from diagram 1 to diagram 2.